Hi everyone, Brenda Gustin here, and this week we're going to be talking about vaccines. Now, your vaccine information is in your textbook in chapter 13, but there's also a lot more information about the immune system and the immune response. I'm hoping that you've had some background on the immune system in another class, hopefully your A&P class. And this will build on that or just kind of solidify some of that understanding. The parts that I'm going to cover are of the immune system are directly related to vaccines and the background of that. So some of this you might have heard before, but I think it's always helpful to hear some of it again. There's also information in this series of lectures that is not in your textbook, but I think is important for you to know, or it just mentions it in your textbook. So I highly recommend using these videos to review for you or to be able to fill out your lecture study guide. So let's start off with the concept of antibodies. And probably most of you, most people walk around having some concept of what antibodies are. They're proteins in our blood, and they protect us against pathogens invading bacteria and viruses and other microorganisms. And you might remember that antibodies are produced by certain white blood cells. And you think about white blood cells as being those cells that defend the body against pathogens. And a subset of those white blood cells are called lymphocytes. So antibodies are produced by a specific kind of lymphocyte called B lymphocytes. You might also hear them called B cells. So B cells or B lymphocytes produce antibodies. Now, antibodies, we have all sorts of different kinds of antibodies floating around in our blood. And how do the B lymphocytes know what antibodies to make? Well, they get exposed to antigens. And antigens are foreign molecules. In fact, the word antigen, it came from the concept of antibody generator. So, for example, a bacterial cell can have proteins on the surface, and those proteins would be foreign to our cells, are foreign to our bodies. Our bodies don't have those cells in them normally. And so it's going to stimulate the immune system, and those proteins on the surface of bacterial cells are antigens, and they're going to generate, they're going to allow the body to generate antibodies. So the antibodies are made by the host, by us, and the antigens are on the surface of the pathogens. This is a picture of a diagram of an antibody, a certain kind of proteins. You can see it's got 4 subunits. And here's another version, another format to show you what an antibody looks like. But antibodies are these Y-shaped molecules. And what you're going to, you probably already know about antibodies, but what you should know about antibodies is these Y-shaped molecules have a region at the ends of the Ys that are unique to the specific antigen. So once antibodies are made to a certain antigen, to maybe a specific spike protein on the surface of a virus, it's only going to recognize that. So we have all sorts of different kinds of antibodies for all sorts of different kinds of antigens. So just continuing the discussion of the role of antibodies, antigens, and B lymphocytes in the immune response is, okay, so we've got antibodies, these Y-shaped molecules floating around our bodies, and we've got antigens, and the antigens would be on the surface of this bacterial cell. So why does that protect us? Well, antibodies stick to antigens, and that doesn't sound like that big of a deal. But your book has a table 13.7, that shows you what antibodies are doing. So all that antibodies do is they stick to antigens. But it's what happens as a result of that protects us from those pathogens. And so here's an example of a lot of antibodies sticking to one bacterial cell. So one bacterial cell can have lots of antigen molecules on the surface. You don't need to memorize these different mechanisms. They might be things that you learned in your A&P class, but just to give you a perspective, if you take bacterial cells and you coat them with antibodies, they kind of can act like flags in the immune system and kind of flag down other white blood cells. You might remember that there's some white blood cells called phagocytes. The macrophages and the neutrophils are phagocytes. Remember, phagocytes engulf pathogens or foreign, engulf antigens, engulf things that aren't natural, or even like dying or dead cells of our own can be engulfed by white blood cells. So white blood cells are kind of cleaning up the blood, looking for foreign things. And if you take an antigen and you put antibodies all over the surface, the white blood cells are, the white blood cells are more likely to find that antigen and engulf it. So it just makes the antibodies, in this case, just make the antigens more likely to be removed from the blood system. Here's one that's showing you that, viruses need to stick to their host cells. Remember, we do that attach. The first step in the viral infection, the virus needs to attach to the host cell. So if you stick antibodies all over the surface, the virus can't attach to the host cell. Here's another example of what antibodies can do. They can cause many antigens or many bacterial cells to clump together. So now that they're clumped together, here's one antibody sticking to two different antigens on two different cells. And so what can happen is now that white blood cell can just come over and take one gulp and consume or remove this whole clump of pathogens from the blood, rather than having to engulf each one separately. So that's just a lot more efficient. There's all sorts of things that antibodies do that enhance the immune response. The next learning outcome we have on your study guide is distinguish among natural active, artificial active, natural passive, and artificial passive immunity. So this table's right from your book, table 1310. And we can divide, how do we acquire immunity? How do we become immune to things? And so it can either be active or passive. If you get active immunity, it means you've actually been exposed to a pathogen, or at least to the antigens from that pathogen. And what makes it active is you make antibodies against that pathogen. So the active part is that the host, the sick person or the person who's been exposed to the antigens, is making their own antibodies. Passive immunity means you're just being given the antibodies. You're not making your own. Somebody gave them to you. Okay, so you don't ever have to have been exposed to the antigen. It's showing you here a mother breastfeeding a baby. The baby's getting antibodies through drinking the milk. So the mother's milk has the antibodies. All the antibodies in the mother's blood are going into the baby through the milk. So passive immunity is going to be acquired when you give somebody antibodies that they don't make themselves, but they can protect that person. The other two categories you want to notice are, so we have active and passive, and then we have natural, and then down here we have artificial. And this is all in the same table, 1310. So natural immunity, it says, is acquired through the normal life experiences of the human, and it's not induced through medical means. So the idea is you can have natural active immunity, meaning it's acquired through a normal life experience. You got exposed to a pathogen and you're making your own antibodies. So the classic example of natural active immunity is getting exposed to a pathogen and getting sick, or getting exposed to a pathogen and your antibodies fighting off the disease. So you might not get sick, but you might, but you're making your own antibodies. Natural active immunity is natural exposure to pathogens. Natural passive immunity again, acquired through a normal life experience, would be breastfeeding. So, or would be drinking the mother's milk that has the antibodies in it. So it's natural because this process doesn't require any kind of scientific intervention or medical intervention. And it's passive because the baby's acquiring antibodies without making them themselves. That can, here I keep saying nursing, but it says even when the baby's in utero inside the mother before it's born, it also is getting natural passive immunity through the mother. So antibodies can cross through from the mother's blood through the placenta to the baby. So they're also getting protection in that way. So that would be natural passive. Here we have artificial active immunity. And so artificial active immunity, artificial meaning it's produced purposely through medical procedures. So artificial, produced through medical procedures, active, you're making your own antibodies. So they're showing you an example here that the child's getting vaccinated. And so the vaccine is through medical procedures, active, they're going to make their own antibodies against that pathogen. And we're going to talk in more detail about those types of vaccines. Artificial passive immunity is medical procedure, but you're not making your own antibodies. So the idea is that if a patient has a certain disease, here it says you can get pooled human serum from donor blood, gamma globulin, which is antibodies, and you can inject, or here they're putting an IV of these antibodies into this patient. This happened with COVID when people, before we had a vaccine, we were able to get people that were sick with COVID and people that had recovered from it. They isolate antibodies from people that had recently recovered and they put them in people that are sick. So those antibodies can fight off the pathogens. So you can imagine that if you have active immunity, it's probably going to be last longer because you're making your own antibodies, and you can continue to make those over a period of time. Whereas when you have passive immunity, that it only lasts as long as antibodies last, and that can usually be about 2 weeks. So if you can't make more of your own antibodies, so look at that natural active immunity. Natural exposure to a pathogen, getting sick, artificial active, getting a vaccine, natural passive, breastfeeding or getting antibodies while in utero, and artificial passive is going to be giving somebody antibodies from someone else to fight an illness. I think I'm going to stop right there and we'll continue on the next topic within section 13.5 in the next video.